Hello and welcome back. So today we're looking at understanding relative frequency. So relative frequency, very simply, is probability that is based upon real data. It's actually based upon data that has already happened. So let's have a look at this example here. A die is thrown 1,000 times and its results are recorded, and they're recorded in this table here. So you can see the die's got numbers 1, 2, 3, all the way to 6 on it. And the die has landed on a 1 150 times, on a 4 52 times, on a 6 91 times. So this is not based on theoretical probability because you'd expect those to be roughly even if it was a fair dice. So this is based on actual data, so actual number of throws. We just treat relative frequency as we do probability. So we can say, what is the probability in this case of getting a 3? You could put RF. I'm going to still stick with the probability of getting a 3 based on this information is equal to, well, 3 occurs 327 times. So it's 327 out of 1,000. So what's the chance of not getting a 2? Well, the not getting a 2 is getting a 1 plus a 3 plus a 4 plus a 5 plus a 6. Alternatively, you could do it 1,000 because it was thrown 1,000 times. Minus 300 means it's 700 out of 1,000. That one's easily simplified to 7 out of 10 because they cancel. And there we go, 7 out of 10. And the chance of getting an even number. So let's have a look at this. Well, we have got 2 occurring 300 times. We have got 4 occurring 52 times. And we have got 6 occurring 91 times. So chance of getting an even number is 300 plus 52 plus 91, so divided by the total number of outcomes. So we just add those together, and that is 443 over 1,000. So just to quickly recap on this, relative frequency is just probability based upon real data. Okay, let's look at another question. Just brought this forward to remind you that relative frequency is just probability based on real data. So in this question, die is thrown 1,000 times and its results are recorded, exactly the same as last time. Question here, is it a fair die? Well, first of all, we need to understand what a fair die looks like. If we look at a normal six-sided die and that was fair, it would have an equal chance of landing on 1, 2, 3, 4, 5, and 6. So that means it's always out of 6. So the chance of landing on a 1 is 1 out of 6. The chance of landing on a 2 is also 1 out of 6. Chance of landing on a 3, 4, 5, and a 6, they are also 1 out of 6. Now, if you add those probabilities up, 1 plus 1 plus 1 plus 1 plus 1 plus 1 is 6, and that is 6 out of 6. So we would expect if we took these probabilities, they should reduce to 1 out of 6. So if we look at these, the chance of getting a 1, we already know, is 150 out of 1,000. Chance of getting a 2 is 300 out of 1,000, and I'll write the rest down now. So here we have each probability, and you can see they are not even. They're not the same, or they're not even close to the same. So because this die has got a few that are significantly higher than others, it's clear to say at this point, after 1,000 throws, this does not look like a fair die because none of these will reduce close to 1 out of 6. Now, the key in deciding if something is fair is deciding whether you've had enough trials. So obviously, if we did this 10 times, we may have a slight bias to one number. As we do it 100 times, you would hope that bias would reduce, and 1,000 times, you would hope that actually that bias would almost disappear and give you the results of a fair die. So in this case, I think it's fair to say that this is a biased die. And if someone said to you, well, what's it biased towards? In other words, it's like someone saying to you, if you were a betting person, which number would you put your money on? Well, actually, that is 3, and then the second one would be 2. They have a significantly higher probability than any of the other numbers. So it's biased towards 3, and then it's biased towards 2. I hope that gives you a really good understanding of relative frequency. The key thing here again is to remember relative frequency is just probability based upon real data. As always, if you've got something from this, please like and subscribe. So our next video is looking at expected probability.